Right. Hi, everyone. Thank you very much for joining us, and thank you for those who will be watching the recording as well. My name is Michal Stefuka, Program Manager for Automation and Customization. And today, together with Stefan, we will take you through the new features of automation and customization. You might ask which particular features. So let's have a look at what is on the agenda for today. We'll start with some minor updates, but I wouldn't say less significant. We'll have a look at some goodies on HWC side of things. We'll have a quick look at new features with extensions, and then we'll jump into the big topic and highly anticipated topic of Python APIs. So without any delays, let me go straight to the first point of today's webinar. HWC language, I hope all of you know. If not, very quickly, it's the recon and playback command language for our post clients that allows you to very quickly put together automation scripts. What 2023.1 brings in is a new set of commands that allow you to control the performance, or in other words, we call it performance mode. Those of you who have scripted in HyperMesh will be familiar with the set of commands that allow you to enhance the performance of your scripts, by, let's say, blocking the graphics refreshing or blocking the browser refreshing. So all the sort of heavy lifting that happens in the background can be temporarily switched off. And this is what the new set of command allows you to do on the post side as well. So mainly HyperView. This is how the command looks. So HWD prefixed and HWC performance, and active equals true will activate the performance mode. As I mentioned, this brings a huge improvements, especially to graphically heavy actions. So as an example, we've got creation of 500 nodes. On the right-hand side, you can see the table. So the time taken for this action goes from plus 40 seconds down to 1.7 seconds. Again, just referring to back to HyperMesh, to the concept of switching on and off performance mode. Very similar approach. On the right-hand side here, you've got a bit of a snippet of a code that you can put in a TCL script, hence the extra HWC prefix in the line of code. You can bring it, as I said, into the TCL script. Between these two lines of code, you can perform the business logic. So it's essentially a performance block that you use to enclose your code within it. And the last thing to mention about it, that although you can use sort of all the defaults that are defined and simply do active equals true and then false to deactivate it, but as a user, you actually have the full control over what this performance mode actually does and controls. Okay, whether it's, as you can see on the screenshot at the bottom, whether it's the control of browser, graphics, or message log. So if you want to control these aspects separately, you can do so as a user. So we hope that you will enjoy this. Although it's a single command, it can bring significant benefits to your scripts, as the little table demonstrates here. Second item on our agenda today are extensions. A few minor updates coming in 2023.1. Let's start with the ones related to icons. So for an extension package, as an author of an extension, you can customize it a bit further, and you can give it sort of your own flavor and create a custom icon. So in the extension.xml file, you can add an extra entry called icon. And on this little screenshot here, you can see that GTA 2023.1 icon was specifically created actually for this extension that Stefan will use later on during today's webinar. If you're not using a custom icon, you can rely on the default ones. We have changed the behavior slightly, and you should see an icon that belongs to the application from which you're actually invoking your extension, or in other words, the application that the extension actually augments with its new functionality. Yeah, that should be per application. A few minor updates that we believe will make life a bit easier when it comes to extension manager in general. So let's quickly view what's there. As an author of an extension, you've always been able to define the version of the extension and also the minimum requirement on the product version. Both of these two pieces of information were mentioned at the top of the screen. So we've essentially, this is a UI change. We have just displayed this slightly differently. So from 2023.1 on, you will see that the version of the extension will appear at the top, just under the name of the extension. And then separately, later on, you will have a minimum required version, which is the version of the product that the extension is for. The entry point for Extension Manager has been renamed. Previously, you would see the Extension Manager link in the file menu. We changed it to Extensions, which is laying the ground for bringing more features within this menu. So although the functionality is the same, we're preparing to bring a bit more stuff for users in the future, hence changing the name to a generic Extensions. And last but not least, we have improved the bar message, the user message that appears in the bottom left corner when you're loading an extension. Again, some valuable feedback from the field. Especially if you're loading a big extension that might be, doing some heavy lifting, the initiation script might be running for several seconds, depending on what the author intended. It's useful to know what's happening and useful to know that this is actually an operation related to a specific extension. So if such operation occurs, you will see in the bottom left corner that an extension is loading, and it will provide the user valuable feedback. And that's what we have changed on the extension side for .1. And with that, we can move on to the main topic of today's webinar, and that is Python API. Python API in 2023.1 will cover the first phase of HyperView and HyperGraph APIs. All right. The first one focused on essential framework classes and the basic workflows for both HyperView and HyperGraph. And Stefan later on will go into more details and show it live as well. Let me start with what I believe is one of the best news with respect to this project, and that is that there will be a full documentation. Let me show you a quick proof of that. The website. So once you get your hands on the 2023.1 documentation and you enter the API reference guides, scroll down and you will see a new link for Python API. Click on the link and it will guide you to sort of a middle or a transition page for Python API. And then you'll need to click on the Python API reference guide, which will take you to a standalone brand new Python API package. At the moment, you'll see 5 separate chapters. We'll start with getting started, just some general information helping you to find the right Python window, understanding how to run scripts. And then the rest is split into 3 sections based on the 3 main modules of the API, so framework package, HyperView package, and HyperGraph package. Each of these packages, on the right-hand side, you will see the list of supported classes. And if you click on specific class, you will see what that class provides, all the related properties, and also all the related methods. Okay, so it's all very much class-oriented, object-oriented. If I go back to framework packages, you will also find some top-level functions like eval HWC, eval.tcl. What I would really like to highlight here is the section of examples. So there's a series of HyperView and HyperGraph examples that you can review and you can use as a basis of your own scripts, either as a template or something to have to start with when you're bringing or coming up with your own Python scripts. Going back to the presentation, we have put a lot of effort into making that API object-oriented. Again, as you saw in the documentation, really most of the operations are about classes and their related either methods or attributes. It fits very nicely to the HyperView workflow. So we hope that users enjoy this approach. If you have scripted in TCL, you will be familiar with the concept of handles. We know that those have not won many popularity contests, and especially the requirement to keep their names unique. So this is something that the user will not have to face in Python. Equally to that, we have removed the burden of hierarchy from the user. So you will not need to jump through multiple different classes in order to get to the final destination. Let's put it that way. huge amount of effort went into synchronizing the APIs in terms of the two profiles that HyperView has, the general and multi-core profile. You might be aware of the big developments of the project and intention to absorb all general workflows in the multi-core profile. So the way we structure the APIs is that if a script is developed for a general profile, it will be runnable in the multi-core profile as well without any change. On top of what we offer directly in Python, users will actually will be able to call HWC code or TCL code through those two functions I mentioned briefly in the documentation, eval HWC and eval TCL. The user experience should be consistent across clients. Of course, HyperMesh, HyperView, HyperGraph, they do different things, they handle things differently, but wherever it made sense, we try to make sure that the logic is as close as possible. And the last point on this slide, users will be able to create custom GUI. It is supported, it is just not yet documented in the Python API package. The GUI module is available as a framework, but users might be available with it from other applications that share the framework, such as SimLab or Inspire. Very quick overview of the modules to make sure you know where to find things and how they're structured. So we've got the main HyperWorks HW module at the top level, which provides you the access to the framework classes such as session, page, window, etc. And hierarchically underneath, we've got the HV module for HyperView client and HG module for HyperGraph client. And before I pass it to Stefan, I would like to go very quickly over a couple of practical examples of the new paradigms that I mentioned on that big overview slide. We said object-oriented nature. So apart from the kind of obvious classes, as I said, windows, pages, and I don't know, results, we try to bring some extras to the user, such as capture image tool class, font class, or color class. Few little examples. Again, in TCL, you would have to run a single command to create a screenshot. We try to change the user experience here. So we create the new capture image tool class, where users can essentially predefine the attributes on an object and then run the capture method of that object. Okay, so it gives you a bit more flexibility. You can create multiple instances, right? One can be creating a JPEG, another one can be creating a GIF or a PNG. You can also use one for specifically putting the screenshot into a clipboard. You can then reuse them at any point within your script without having to redefine all the attributes again. Similar, the font and the color, it can be directly specified on an object. We didn't want to kind of overcomplicate things for the user, but at the same time, you can create an instance of a font class or of a color class and then use this object as the definition of that specific property on your either a node or a curve. I would also like to highlight here on the bottom snippet that a color class, as it's been designed, is very, very useful for also converting the color values. So although we defined a color as a set of RGB values, we can then query the hex value. You can also query the BGR if you're with that, and at the end, use it as the assignment of the line color. I mentioned there is no strict hierarchy. As a quick example, if we want to adjust the levels of a legend, you don't have to go through the window and the model and let's say the contour control, right? I can simply step into the HV module. I can get my handle on the legend scaler, and I can straight away just adjust a number of levels. So without any sort of burden of going through multiple levels of classes. What this screenshot or this snippet also shows you is that we have implemented user-friendly defaults. In the middle line, I'm not specifying which particular legend scaler I'm working with. By default, we grab the active one, so from the active window, active page, active model. So again, trying to simplify the user experience as much as possible without any extra burden on the user. If you want to work with a specific legend, on page 7, window 3, model 2. It's all possible, but it's not necessary. And last point here from my side, when you're referencing an object, in TCL, classically you would work with IDs, possibly strings. Of course, in Python, you can work with the object. So wherever it made sense, we focused on that object-oriented paradigm. But again, we didn't want to overdo it. So wherever it is convenient, we're providing sort of a union of arguments for users, and they can choose how they want to refer to a specific entity. On this little code snippet, you can see that we are getting a curve object, so a handle on an existing curve, and we're defining in multiple different ways, either through the displayed label, through the coded label, or I'm specifying the ID of the curve. So again, users should be able to find their most preferred ways, and without having to jump through maybe multiple lines of code or creating any workarounds. So really hope that the user experience will be appreciated. And yeah, with that, I will let Stefan show you all this in practice and kind of prove that it really is in the 2023.1 release and that you can enjoy it very soon. So thank you.
My name is Stefan Eberhardt. So let's start with the HyperView Python API phase 1. So let's quickly go to the class coverage. You see here the framework class is already highlighted on the right side, which are page and session and animator. For HyperView specific, we have from the window type animation specific attributes and properties covered. We will have the whole result and legend stuff covered. From the entity side, we have model parts, editor element and nodes covered. And we cover collections for these entities, filter classes as the 3 filter classes we know from the selection set, and the Boolean operations. So if you want to combine 2 collections, you can plus and minus these collections. And then we also have the export model H3D in phase 1 covered. So let's show here when stuff is missing, you can integrate existing TCL commands using eval TCL. So here a little example. Here I used in Python the post query package. I load it and then get the component list here, both with IDs or by name, and use with basically eval TCL get both lists. Doing this one in Python, I created here a part collection of type part. Populate is by default true, similar to HyperMesh. So if I create a collection, it will be full, all the parts will be included. And then I get the lists and print those via Python. So this is the output, as you will see in the console. I will show this live, and before I go here to application, you will see here the GTA 2023 extensions. I loaded it via file extensions. And this extension we will put on Altair community as soon as 23.1 is out. So everybody can see it. Let's have a quick look inside of this extension. You will see here the extension with the ini.py and initTCL file, and all the demos you will see are here included. Okay, for this eval TCL, when I run the code, I already showed you here, the model is loaded, and then here with eval TCL, both the lists, the ID lists for part ID lists and part name lists are created with these different methods. So next, I will start with a very basic HyperView example. I load the model, I contour it, and then export H3D and image. So this is the classes and methods we will use. You see on top, get the session pointer, the session to get the entities, also similar to what we will have in HyperMesh. Then on the window class, I load the model and the results. I created results and result definition objects to plot the results. And with the animation tool, I will create this one to modify the frame so that and then last not least, I created two export tools, the export model H3D and the capture image tool, to export this stuff and export the image and the H3D. Let's go there and run it. The model is loaded, it's fitted, and then it is exported. When we look, it should be here on the out tier. It's just created, and we will see the image and the H3D currently created. Let's go to the next example. This is a little bit more challenging. So I created my own hotspot finder via Python. So the class and methods I used here, I created a collection. Here I use populate false, a collection of type element. So this collection is empty. I created a filter by scalar object with the operator top n and value 1. And I have then filled this collector with this top 1 element. The next step, I get from the collection the entity list, get the first element and the centroid of it. Then I created another collection also of type, entity type element, and also with populate false. And then I created a filter by sphere with the x, y, z coordinates of the found element and added basically the elements in this sphere to the sphere collection. I plotted here with the result scalar definition, only the collection with the spheres collection, so limit the collection and then plotted it with the result. I used here eval HWC. I will show it later in more detail. So because we haven't covered views yet, so I just record the view and put it in, and then I will show it here. This is the max by sphere. So it's loaded and run. So that was the code you have currently seen. Maybe we have a quick look at the documentation. This was the max by sphere display top n. This is the script which I showed parts of it, which is currently running. You will see the node which I created, because we also haven't covered nodes yet, was also created via HWC. The next one for HyperView, I create a macro with GUI support and loop over a whole bunch of results. The class and methods here, I use the HWX GUI toolkit Mikhail already mentioned to create the dialog. Then, in addition to the classes we already seen, I use the page class to modify the layout. Use the legend class. Here you see I reduce the number of levels here and change the settings and fonts. And then I also use the result division ISO. I capture from the legend max min and set it to 20% of the range, etc. So the whole thing. And and then I export everything. During the export, I create H3D and images out of it. So I run here the tool with the macro GUI. You see the GUI and I run. And now you will see for each of the result types I defined in a dictionary, I loop over and made the different X, Y, Z data components, set it, and jump back to the beginning. And let's have a quick look. Here you will see this is done. Oops. And you will see here, that all the results here are exported, images and H3Ds. That finishes the HyperView part of the presentation. Let's go with HyperGraph. HyperGraph, again, we start with the class coverage. So here you see the framework coverage. There are less classes in HyperGraph, obviously. So we cover the HyperGraph specific for XY plot. So it's just XY plot, not complex or bar charts or so. The relay window specific attributes and methods. We have curve XY and math XY classes, please be aware we have no vector classes like in the legacy API. All the properties like X vector, X expression, Y expression, X request, etc. It's all on the curve. You don't need multiple objects to create a curve. And then we have all the date, node, datums, header, legend, etc. We also included the export curves so that you also in phase one can run a full workflow cycle. So the first thing I want to show, the integration here with eval HWC. So you can use the HWC wrapper and include the stuff in single quotes. Why I show this here in HyperGraph? So we have no build plots yet covered. So I just loaded with the more normal build plots generator. I loaded a bunch of requests and components and created some plots. And this is the stuff which is recorded. I can easily throw this in the eval HWC wrapper. So I go here to the HWC and I say clear it. And then now I run the Python script. This is eval HWC. You will see it will run the code, and now you will see reverse that the stuff is loaded, the layouts are created, and then all the math and everything is done the way, and you will see that the Python running this Python code will create now the HWC code. I haven't turned the logging off. I can turn the logging off, but for demo purpose, I kept it here running. Okay, the next example, I want curve for math expression, very simple. The class and methods, again, session, we need the curve XY to create the curve. I just used here a bunch of expressions, and some curve names and simply create it. We will see this live. So math curves, whoop, it runs the code you have already seen and it's created. The next example I want to show is we load curves, we do some more stuff. We load multiple curves from type file. We add datum lines at the vertical ones at the maximum. We add nodes, we position them, we control them, etc. So the classes we use is curve XY to create the curve and shade it, etc. The math XY class to add the math, then node legends datum. Here I show just node and legend. To create a node, here the legend is a singleton, so I just get the pointer and modify the font size or the datum. I can use the window class to update. This is very simple. So normally you have to do fit, recalculate, and draw, but we have also commands to do this all in one shot. And then last but not least, we see the capture image tool we already have seen, but also the export curves tool, which allow me to show for the whole session or plot or window, etc., to export this one. So I run this one, export curves, this code, and you will see here. So now let's go here. Maybe see some code in action. I go here and load something. So run some code snippets. For here, I import HW and then also HWHG. And I already created the session object, curve object. This one has no page window, and this one will get the first curve in the active window. A math object, if nothing is given, like here below, I give page window curve or so, but this one, the math object will get the first math entity of the first curve in the active window. Okay, when I want to see m dot, I can see what kind of operation or whatever, I can click here, click it, or m dot padding, mirror padding, I can change it. But when I go further, I want to say, okay, I have this math object and which is the parent. I want to get the curve. I get the object. This doesn't tell me a lot. So I can, from this object, the ID or label, or maybe label as displayed, because this tells me a lot more. So get this one. I want to get, now I even want to modify maybe the page where the curve with this math operation is on it. I can go even further and say math.curve. This has a window object will be returned, the page object. What is the title of this one? You know, title. Okay, it's untitled. I want to change this and say new title. And you will see here the page change to new title. Last of the live hacking is maybe from the curve. I want to see, okay, what is the math I have done and can I reuse it? So I say curve math, and here I get math copy, math edit, etc. Okay, I like the math with all the settings. I say math copy and get here a dictionary, which I can save. I can put it with math paste on other. For now, we can throw it to another curve, save it, reuse it, and all the information is there. Okay, that gives a quick how to work. And now the last for HyperGraph, I just want to see I have a bigger script which has here dictionaries with a lot of requests and component, looping over pages and windows, and all the objects, the classes and methods you have already seen will be executed. Running this one multiple pages, you will see here how its position, nodes, actions, datum lines, everything will be created. This concludes the Python part. I quickly want, Mikhail mentioned that, so this is created. The performance mode, I quickly want to show a live demo of this one. So the creation of 500 nodes. So if you create a node, it will be recorded the creation, then if you attach it, etc. So 3 lines will be created. In this script, when you run it without these lines, you need here 40 seconds around and here 1.7 seconds. No, we don't want to wait 40 seconds, so I limited here the list to 200 nodes. And you will see here, if we run it without the performance mode, you will hopefully see in the Teams transmission that how they are created one by one. And for 200, it's 9 seconds or 10 here. It's done. Now I delete, you see the recording, the recording was done from the script. I haven't blocked it. I clear it. Now I go to the performance mode on. The model is loaded, and now, whoop, 1.8 seconds, 500 nodes are created. And when I click OK, you will see the performance mode was active and nothing, no browser update, nothing. And when the script runs to false, yeah, that's then now the GUI is again reactive.